Hello everyone, I'm Hwang from the School of Integrated Technology at Yonsei University. I'd like to take this opportunity to present my findings on my research titled Anomaly Score, Evaluating Generative Models and Individual Generated Images Based on Complexity and Vulnerability. Generative AI has been improved with the advancement of DNN so that many generative models could be developed. As the number of generative models increase, evaluating them has also become increasingly important. Many researchers developed methods to evaluate generative models by utilizing distances between extracted features by pre-trained classification models. However, several researchers have argued that such metrics are often misaligned with the human judgment on naturalness. Let's consider a pair of real images. They have this much of a feature distance between extracted features. We can assume a modified image, noise-added image, having the same distance. In this case, can we say that the modified image is natural like the real image because it has same distance to the pair of real images? As you can see from this example, feature distance is an insufficient metric when assessing the naturalness of an image. Now, let's take a closer look at the overview of our research. In order to examine the characteristics of the representation space, we first introduce complexity and vulnerability with an in-depth analysis of the representation space. Then, there are two kinds of evaluation methods, model-level evaluation and image-level evaluation. We suggest the anomaly score for the first one and the anomaly score for individual images for the second one, utilizing complexity and vulnerability. We analyze representation space in two different perspectives, complexity and vulnerability. First, complexity indicates how nonlinear representation space around an image is with respect to linear input changes. With several bases, we assume that the representation space around generated images is less complex than that surrounding real reference images. The definition of complexity is as follows. We calculate the angle between the changes of the output feature within two successive steps. As a result, the complexity of reference images is larger than that of the generated images. Let's take a look at vulnerability. Vulnerability indicates how easily an extracted feature is changed by adversarial input changes. With several bases, we can assume that generated images are vulnerable to the adversarial perturbations. The definition of vulnerability is as follows. We use modified PGD update rule to find an adversarial perturbation, making attacked images feature far from original images feature. As a result, the vulnerability of generated images is larger than that of the reference images. We explored the relationship between vulnerability and naturalness with an MVT dataset. As shown in the graph on the right side, the MVT level is highly correlated with vulnerability. In a nutshell, low naturalness is related to high vulnerability. By the discovery in the analysis part, we proposed an anomaly score for evaluating generative models. We measured the difference between the bivariate distributions of complexity and vulnerability by utilizing two-dimensional KS statistics. As a result, the anomaly score shows high correlation with the human judgment with overall generated datasets. For individual datasets, an anomaly score with DynoV2, ConvNext, and VIT is well aligned with human error rate on Cypher10, ImageNet, and FFHQ respectively. Furthermore, We can check that an anomaly score using both complexity and vulnerability shows a high performance. We suggested an anomaly score for individual images using complexity and vulnerability. The definition of the score is as follows. We conducted subjective tests to compare our method to two existing methods, the rarity score and realism score. The table on the left shows that as the ASI level increases, fewer images is a subset are judged as natural in a consistent manner, while other methods are not aligned well with human perception. Thank you all for listening, and you can find more information about the results of our experiments in our paper.